Hey, what's going on, guys? Nick here with Seku Technologies, and I'd like to welcome you to the second installment of our JavaScript series on objects, methods, and events. Now, you might be thinking, Nick, what the heck are objects, methods, and events, and what the heck do they have to do with JavaScript? I mean, I understand them in a real world perspective, but how am I able to relate that to programming and coding? Well, it's going to be important for us to remember that JavaScript is an object-oriented programming language, which is nothing more than a paradigm that uses abstraction to create models that are based on the real world. Okay, that's going to be key. It creates models that are based on the real world. Object-oriented programming uses several techniques from previously established paradigms, including modularity, polymorphism, and encapsulation. And if I just confuse you with those big words, do not worry. The key takeaway is going to be that JavaScript creates models that are based on the real world. Okay? So what do I mean by models? Well, whenever we program, the computer needs a model to follow. Remember, it needs some type of recipe. It needs some type of schematic. Those models consist of objects, they consist of methods, and they also consist of events. Computers have no predefined concept of what a real world object actually is. So if we take a look at the picture to the right, what do we see? We see an apartment building, we see trees, we see cars, we see the road, we see the sky, we see the light. All of these are objects in the real world. We have the capability as humans to interact with them. We can change the properties of them. We can update them. However, when it comes to a computer, the computer doesn't understand that that apartment is an apartment. To a computer, that apartment can be a car. That apartment can be a dog. That apartment can be a boat. It does not matter. However, to us, it means something. And that's what programming is about. We need to take these real world objects and we need to place them in such a way that the computer can understand and also have the capability to carry out a particular function. So how do we make these models and how do we model our real world in a programmatical perspective? We make these models using data, all types of data, pictures, numerical text, string text, videos, any type of content, any type of data type. This is what we use to construct a model for programming. So that leads to the first one, objects. I just explained it a little bit, but in the picture to the right, what objects can you see? We have the apartment. We have the little red columns on the apartment. We have the trees. I see a bench, or at least what looks to be a bench in the bottom right hand corner. I see the cars, I see a light pole. All of these are objects. Objects are nothing more than things. I'm recording this video in my room right now. This microphone is an object. The pillows on my bed are objects. The carpet is an object. My dresser is an object. The ceiling fan. Objects are all around us. Each physical thing in the world can be represented as an object. Now, to further break it down a little bit more, each object has its own particular property, it has its own particular event, and it also has its own particular method. The first one of these that I want to talk about is properties. And it's quite easy to understand. Whenever we think about objects, for example, whenever I talk about my bed, remember my bed is an object. Well, a property of my bed is that it's comfortable, it's large, it's small, it has wood, the color of it. All of these are going to be properties of objects, and we can think of millions of properties for all of the objects that we see on a day-to-day basis. So taking a look at the cars within the picture, some properties of the car is the speed, also the color, which is bronze, the model of it, the gas, anything about the windows, anything that we can physically say about the car, anything that we can also physically see about the car is going to be a property. Some properties of the apartment, the color of it's white. It looks to be approximately 200 feet high. The name of it, I just said relax apartment complex. I don't know. The number of units is 60. Does it have a pool? Does it have a gym? All of these are properties of the apartment, properties of objects. Now, talking about events. In the real world, people interact with objects. If I wanted to interact with my bed, I could go to sleep. I could lay down on it. These interactions can change the values of the properties of these objects. For example, if I lay down on my bed over the course of 10 years in the same spot, chances are that particular mattress is going to get worn out. As a result, I'm going to need to do something. It's going to be the same exact thing when it comes to programming. Programs are designed to do different things when users interact with the computer in different ways. For example, clicking on a contact link on a web page could bring up a contact form. Okay? We're going to interact with different pieces of the content within our web page, which is going to lead to a particular event, which is going to have us carry out a particular method. We're going to have to do something. So using my bed example, if I lay on my bed over the course of 10 years and it gets worn out, well, the event is that it gets worn out. And as a result of it getting worn out, then I'm going to have to purchase a new mattress. That's going to be my method. Consider our car. I just like putting everything into perspective. The car drives, the car accelerates, the brakes make the car slow down. All of these are methods. When a specific, events. When a specific event happens, that event can be used to trigger a specific section of the code. Okay? So just a little bit more. We have our car. The event is, let's brake. Well, how does he brake? How does the car brake? The driver has to slow down. Accelerate, the driver has to speed up. Honk, the driver's going to be more alert. For every action, there's an equal yet opposite reaction. It's the same exact thing with programming. Same exact thing with programming. We have events, we have objects. Any particular event is going to happen. The computer is going to react in some sort of way based off of our programming code, which is going to lead to the methods. Remember, I lay down on my bed, gets worn out, I have to go purchase a new mattress. The methods represent things people need to do with those objects. They can retrieve or update the values of an object's properties. They represent how people interact with an object in the real world. I'm going to use the TV as an example. The TV is an object. The TV comes on. Well, I want to go to bed. So what am I going to do? I'm going to carry out a method. I'm going to turn off the TV so I could go to sleep. Or I can then lay down on my bed. I do this time in and time out over the course of 10 years. My TV gets worn out, so I'm going to have to do the method of now purchasing a new TV, which is going to update the properties of my object. Same exact thing with the bed. I purchase a new mattress, I update the properties of my bed. Makes sense, right? It's all beginning to come full circle. How we see it in the real world makes perfect sense. We are actually computers. Our brains are beginning to now think like computers. Everything that we come into contact with, we are able to translate that into a programmatical aspect. These methods tell us something about a particular object using the information that is stored within those properties. In programming, the code for methods can contain lots of instructions that together represent one particular task. So, in the case of our apartment, the apartment staff will commonly be asked if they have any available units. To answer, a method can be written that subtracts the number of bookings from the total number of units, or the number of leased units from the total number of units, right? Methods can also be used to increase and decrease the value of the number of properties that have been leased. For example, these are how some methods could potentially look in this case. If I'm interested in a particular apartment, I said, you know what? I want that one. That's going to be the event. I want this particular apartment. The method that I'm going to carry out is I'm going to sign my lease. Well, as a result, this is going to increase the number of leased properties at that apartment complex, and vice versa. Over the course of a year, my lease is going to run out. I might have to move, or I might have to sign a new lease. I don't know. However, my lease is going to end. That apartment is going to become available, and that is going to increase the overall number of those available apartments. Now, if I want to check the availability of a particular apartment, I'm going to subtract the number of leased units from the number of available units, and this is going to display the number of available units as a result of leases that have been signed and leases that have ended. Right? Makes perfect sense. All of these methods come at the result of an event. So putting it all together now. Remember, computers use data to create models of things in the real world. The events, methods, and properties of a particular object all relate to one another. Events can trigger methods, and methods can retrieve or update an object's properties. Once again, when an apartment is leased, the lease event is going to fire. Somebody is going to want to move into that apartment. The lease event is going to trigger the sign lease method. That individual is going to sign that lease, and as a result of them writing down their John Hancock, putting their signature on that lease, that is going to increase the number of leased properties throughout the complex. The value of the number of available units properties, remember at one point it was 60. However, since an individual went in and signed a lease, this took the number down by 1, meaning now the number of available units is at 59. All of this can be done within the methods that we choose to write. And that's one of the things that makes programming so powerful. One of the things that makes programming so strong is that we can literally encompass any object, and we can, sounds like the cops are coming for me. We can literally take any object and we can relate that object in a programmatical world and have the computer do anything we need it to do. So, no class will be right without homework, right? Your homework is to write out a series of objects, methods, and events that you encounter in your everyday life. This is going to help you because you will conceptually be able to understand programming a little bit more. And if you are ready to code, that is going to happen in the next video. So go on ahead, get your homework done, turn it in so I can give you an A and we can finally get to coding. Take care, guys. See y'all in the next video. Bye.